Virginia today is speaking from the Advanced Communication and Leadership Series, Speaking to Inform. She's doing project number 5, Abstract Concept. Virginia's objectives for today are to research and analyze an abstract concept, theory, historical force, or social political issue, and to present the ideas in a clear and interesting manner. Virginia's time that she'll be shooting for today is 7 to 9 minutes.
Virginia is not a scientist, but she loves history and reading about great events and discoveries. Today, she will share what she learned about Einstein and relativity. Einstein and relativity, Virginia Edwards, Einstein and relativity.
Mr. Toastmaster, fellow Toastmasters, and guests, is there anyone here who has never heard of Einstein or the theory of relativity, except the young man? Didn't think so. I'm not going to ask you to explain it or tell me if you fully understand it. I know I don't. And I don't think anybody but top physicists totally understand the theory of relativity. It is probably the most famous equation in history, and probably the least understood. Now, Albert Einstein is also the most famous physicist and probably the most famous scientist of all time. His name has become a synonym for genius. Call people Einsteins. He spent his life trying to understand what was happening in the world, and it started when he was a very young child. Now, as I said, Albert Einstein is known for the theory of relativity, but there are actually 2 theories of relativity that he developed. The first one is called the theory of special relativity, and then a number of years later he came up with the theory of general relativity. Today I'm only going to have time to talk about the theory of special relativity. And this theory was promulgated in his most prolific year, 1905, when he developed 4 major papers in the field of physics. And what was he doing at that time? He was working in a patent office in Bern, Switzerland, and he was in his mid-20s, and he had not been able to find a job teaching after he finished his university studies. Einstein did not invent relativity, Galileo did. But Einstein's development of these theories shocked the world and has forever influenced scientists, science, all forever and up into our own day, and changed the way we think about certain things as well. What is this famous equation? Well, most of us have always heard it, whether we know it. The equation is E equals mc squared. Now, there were papers. Einstein didn't write this, just this little, theorem on a piece of paper, and this was all it was. There were lots of other equations, and mathematicians would understand this. But this is what it's known as, theory of special relativity. E equals energy, m is mass, and c is the speed of light. So the equation reads energy equals mass times the square of the speed of light. Energy equals mass times the square of the speed of light. Now, the speed of light Einstein found was a constant, 186,000 miles per second. Nothing can go faster in the universe than the speed of light. It's the universal speed limit. And it has become a constant in physics since that time. Now, if someone was riding on a train, one of his favorite examples, and looking out the window, and another train is going by, moving faster than the train the person is in, the person in the train has no way of knowing what his or her absolute speed is. They can't tell that. If the two trains are moving together at the same speed, it's like they're at rest. So his theory, an object cannot get any information about its speed by comparing it with another object. Einstein would say that all measurements are of this type. That is, they are all relative. Every measurement is relative to something else. Now, in 1905, scientists thought there was some absolute thing, they called it the ether, against which you could measure all motion. But Einstein proved that that wasn't true. There is no fixed point of reference for all motion. And that is the theory of special relativity. So think about this. If you're in an airplane and you got a magazine sitting on your lap, that magazine is not moving in your frame of reference. But if you look out the window, the whole world is moving backwards relative to you. But the magazine is not. E equals mc squared also says that energy and mass are just two aspects of the same thing. A hot potato has more energy than a cold potato, but the difference is so infinitesimal that we don't really have the measurements to do that. So where this comes into play is when you have large quantities of mass and energy, like the amount of energy required to move something at the speed of light. This formula says that a tiny amount of mass moving at the speed of light can produce enormous quantities of energy. A kilogram of mass can produce 85 billion kilowatt hours of energy. Or, looking at it another way, as they have said, a gram of a raisin in this formula could produce enough energy to serve the city of New York for a day. If they could figure out how to do
It's really hard.
it. It took years for this theory on all the aspects of it to be proved. Scientists started, principally physicists, started doing experiments on this for years. Many scientists, many theories, many attempts at all of this. The most dramatic effect of this principle was the atomic bomb explosions. As a pacifist, Einstein was horrified by the atom bomb. But Einstein's theory here also explains why we have the sun that can burn so brilliantly for billions and billions of years. Why? Because the sun is so efficient at converting matter to energy. Now, we say things are simultaneous if we see them happening in our frame of reference at the same time. So imagine if you are standing, a person is standing in a field, equidistant between two trees. Let's say this is an oak and this is a maple. Lightning strikes the trees at the same time. Person is stationary. The light travels at the same speed, so the light from the two trees is going to hit the person's eyes at the same time. It's equidistant, so they're traveling at the same. However, if someone was in a car moving between these two, and the car passed the midpoint before the lightning hit the trees, then the car would be closer to the maple than to the oak. So the person in the car would see a flash before from the one side of the lightning on the maple tree because it had to travel further, not because it was faster, but because it had to travel further. So in that person's frame of reference, the lightning strikes were not happening at the same time. Well, this theory of the relativity of time also blew the scientists' minds in 1905, because time was thought to be a constant and not changing, a basic. And so they couldn't understand that. But Einstein proved that time is relative again. If two observers are stationary and they see the same thing, they will and measure the time at the same rate and have come up with the same value. But if one of them is moving relative to the other one, and especially if they're moving at a rapid rate, then they will come up with different answers. Still correct for their frame of reference. Now, even in the 21st century, physicists are still developing tests of the theories of relativity of Einstein. It goes on still today. Even those of us who are not physicists, I think, can find Einstein and his theories very fascinating. Einstein's whole life is very, very interesting. And I read this book recently. There's many books, many papers written about Einstein and all his theories. This book is called Einstein, His Life and Universe by Walter Isaacson. There is one particular thing that Einstein said that I think is so applicable to all of us. A person who never made a mistake never tried anything. Mr. Toastmaster.